Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTO syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive latest lectures as and when it is uploaded in my YouTube channel. Now let's start the session number 39, which is based on pneumatic actuators. Actuators are those which has motion or to which motion can be imparted. If the motion is imparted by energy contained in air or gas, then it is called as pneumatic actuator. Pneumatic systems also use actuator similar to hydraulic system except air is used as the operating medium. Since the operating medium is air, pressures are lower and hence lighter in construction. The pneumatic actuators are broadly classified into three types, namely linear cylinder, rotary actuators, and air motors. What is called as linear cylinders? Linear cylinder in pneumatic system is also called as air cylinders. Air cylinders are generally made up of either aluminium or non-ferrous materials including plastics to reduce weight and improve heat transfer characteristics and minimize the corrosive action of air. Air cylinder essentially consists of a tube sealed at both ends by covers and fitted with a piston and piston rod. Compressed air is admitted through a port at one end which produces linear motion of the piston. Displaced air is exhausted through the same port or through the other port depending on whether it is a single acting or double acting cylinder. Now let us understand the classification of air cylinders. It can be classified as basically the pneumatic actuators as we already discussed, that is linear cylinders as or air cylinders, rotary actuators and air motors. And again this linear cylinder will be subclassified based on operating principle, construction, mounting arrangement and the load that can be applied. And on the operating system, it could be either single acting or double acting. And even single acting will be either diaphragm or rolling diaphragm type. Each and everything we are going to discuss in the following slides. Now let us understand the working of single acting cylinder. In case of a single acting cylinder, compressed air is applied on one side of the cylinder which extend the cylinder, that is nothing but the piston. You can see the respective figure over here. The method of retraction depends on the application of the cylinder. If the cylinder required to produce high force during extension, as in clamping or forming operation, and very small force is required to retract, then a spring is used to retract, which you can observe the figure A. But the length of the cylinder has to be increased for a given stroke to accommodate the spring. If the cylinder is used to lift a load, the gravity will retract the piston, which you can observe it in the figure B, called as gravity retraction. Then how does it is going to have a construction? Let us understand the construction part. Pneumatic and hydraulic cylinders are constructed in a similar manner to that of a hydraulic cylinder. The major difference arising out of differences in operating pressure, approximately around 10 megapascals for hydraulics and 1 megapascal for pneumatics. A single cylinder consists of the following main part, which you can see there: the two end covers, cylindrical tube, piston and piston rod, spring and tie rods. The figure shows the assembled view of an air cylinder. The cylindrical tube is held in position by two end covers with the help of the tie rods. The piston rod assembly consisting of a cup seal reciprocates inside the cylinder, the retraction being affected by the spring. The compressed air enters the inlet port of the cylinder and extends it to the low pressure air is expelled through the exhaust port during retraction. Both inlet and outlet ports are provided in the piston end covers, which you can observe in the figure over there at the bottom. The location of the spring is either on piston side or on rod end side, depends on the application of the cylinder. In spring, on piston rod side, the piston is extended by compressed air and the spring retracts, which you can see in the figure here on the right hand side of the slide. In case of a spring on the piston side, the piston is extended by a spring force and air retracts it, which is represented by figure B on the right hand side of the slide. This type of cylinder are used in air brake of trucks, rail coaches, etc. The other types of single acting cylinders are diaphragm cylinder as well as rolling diaphragm cylinder. We'll understand the concept of diaphragm cylinder now. Diaphragm cylinder consists of a built-in diaphragm of rubber, plastic or even metal, which you can see in the figure. Diaphragm cylinders are capable of generating very high force with very short strokes and are commonly called thrusters. Theoretical thrust is equal to the product of air pressure and effective area of diaphragm. Stroke is normally limited to a maximum of about one-third the cylinder diameter. Normal positioning is either vertical or horizontal. Then coming to a rolling diaphragm cylinder, as the name indicates, the diaphragm rolls inside the cylinder and the piston fasten is extended. And the figure on the right hand side of the slide shows the graphic symbol of rolling diaphragm cylinder. Then coming to double acting cylinder. In double acting cylinder, each end is pressurized by compressed air alternately, thus developing force on either direction. Since compressed air acts on either side of the piston for extending and retracting of the piston, the cylinder is called as double acting cylinder, and this figure shows the basic principles of double acting cylinders. Upon construction, a double acting cylinder consists of two end covers with one port on each, a cylindrical tube, a piston rod, etc. End caps can be secured to the two ends of the cylindrical tube by welding, tie rods or threaded conditions. To prevent any leakage through the cylinder, seamless drawn steel tubes are used. And in the previous slides, whatever the figure you have seen, that shows the cross-sectional basic constructional features of double acting cylinders. Either cup or seals with o-ring may be used for piston assembly, which you can see in the present figure. That is methods of piston assembly. The materials used for different parts are, for cylinder, stainless steel, aluminium, or it could be a brass tube. For piston, it should be a cast iron or steel. And coming to end caps, cast form of iron or aluminium will be used. Now, how does it work? Let us understand by this figure on the right hand side. In the normal position, the cylinder will be retracted position. High compressed air is allowed into the piston through port A by actuating a 4x2 direction control valve. The piston extends and the air on the rod end side of escapes through port B. Delivery of high compressors air into the cylinder continues till the extension is complete. Similarly, high compressed air is allowed into the cylinder through port B and the piston retracts. The air on the piston side escapes through port A during retraction. Compressed air continues to enter the cylinder through B till the retraction is completed. Now you can see the same in the figure on the right hand side of the slide, which shows the circuit diagram of the working of a double acting cylinder. So by this we have reached to the end of the session. Thanks for your patience listening. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavardhan.